Hi friends, welcome to Veteach. In this session, I would like to explain about solutions of difference equations using jet transformations and system function. Actually, the solutions of difference equations we already learned without using jet transforms. How to find natural response, how to find forced response. And the same concept, the same problems, you can solve it using jet transforms also. So first topic, let me concentrate on system function. So system function is nothing but h of z, h of z, and h of z is y of z by x of z. Suppose if a difference equation is given in terms of y of n and x of n, apply jet transform on both sides and bring that expression in terms of y of z by x of z, and that is nothing but h of z. It is called as system function, y of z by x of z. We will see the numericals also. Then from system function, after finding system function, you can find poles and zeros. Poles are the terms related to denominator and zeros are the values related to numerator. So poles and zeros, if the system function is written like this, z minus z1 into z minus z2 into z minus z3 in numerator, likewise in denominator z minus p1, z minus p2, z minus p3, where in numerator z1, z2, z3 are known as zeros, z for zero there, and in denominator p1, p2, p3, p4 are known as poles, p for pole. So now m is up to capital M we have taken here, and here up to capital N we have taken. So capital M is number of zeros, capital N is number of poles, and zeros, they are represented by a small circle. Poles, they are represented by a star. For example, take this example, we have z into z minus 1 divided by z minus 1 into z minus 1 by 4. So in numerator we have two terms, z and z minus 1. That means z equal to 0, z minus 1 equal to 0. That means z equal to 1. Z minus 1 equal to 0. We have only two poles, z equal to 0 and z equal to 1. So two poles are represented by circles at 0 and at 1. And denominator z equal to 1 by 2, z equal to 1 by 4. Two poles. So poles are represented with a cross mark. So this is the way how to determine poles and zeros. If you go for solutions of difference equations using jet transformations, directly look into the problem. Y of n plus 3 by, it's minus y of n minus 3 by 4 into y of n minus 1 plus 1 by 4 into y of n minus 2 equal to x of n plus x of n minus 1. And for this problem, we need to find the solution. The same problem without jet transform, we determine natural response, forced response, and we combine those two responses for the total solution. But here, by using jet transforms, how to find the natural response, how to find the forced response. So natural response means, go back to the basics, input is 0. So all x of n terms are made 0. And if you apply jet transform on this, and jet transform is one-sided jet transform. So for one-sided jet transform, for time shifting property, this is a formula. So apply one-sided jet transform, and then you will get an expression like this for y of z. So after getting an expression like this for y of z, you can determine y of z by using partial fraction method from y of z to y of n, that is inverse jet transform. For determining inverse jet transform, we have power series method, partial fraction method, residue method. The simple one is partial fraction method. You are familiar with partial fractions. So partial fraction method you can use there, and you can find y of n. Your answer is finished. Likewise, for forced response, again the same thing. Input is applied there, and in the question input is given as u of n. Again apply jet transform on both sides, and you will get an expression for y of z. After getting expression for y of z, again apply partial fraction method, and you will get expression for y of n by using partial fraction method. So y of n is calculated. So this is the way how to find the solutions for difference equations. System function. How to find system function? The question is given y of n equal to x of n. Y of n terms are given, x of n terms are given. Apply Z transform on both sides. This is our given question. If you apply natural Z transform on both sides, you will get y of n Z transform is y of z. Y of n minus 1 Z transform is z inverse into y of z. Y of n minus 2 Z transform is z power minus 2 into y of z, time shifting property. X of n Z transform is x of z. X of n minus 1 Z transform is z power minus 1 into x of z. So after applying Z transforms onto the left hand side, bring out an expression for y of z by x of z. So y of z by x of z is nothing but h of z. That's what it is written, system function, or you can call it as frequency response. Okay, h of z equal to y of z by x of z. You will get an expression like this from that formula. So you can stop here. So this is system function, and onto this system function, if you want to find frequency response, put z equal to e power j omega. Actually z is equal to r into e power j omega, but r is 1. That means if you are evaluating this Z transform on a unit circle, then r equal to 1. This is our frequency response. So in this session you learned about solutions of difference equations using Z transforms and how to determine the system function. Thank you.